Hi guys, this is worksheet number 9, and it's a little more practice with, trying to work with the ideal gas law and how to use it to look at density as well as molar mass. So what we're going to do today is we're going to work with this formula a little bit. So big M is molar mass. So this one is molar mass. And we are able to tell the molar mass of something using the ideal gas law if the conditions of temperature and pressure are not ideal. That is 0 degrees Celsius and 1 atmosphere of pressure. The little m here then is the mass of whatever we're looking at in whatever conditions of temperature, pressure, and volume we're looking at. Now, also notice that mass over volume should look familiar to you. And if you're saying, wait, that's density, you're absolutely right. So we can actually substitute density in here as density RT over P if we need it, which we will. So your homework today is going to be problems 1 through 5. I'm going to help walk you through problems 1 and 4. Include them in your upload, but again, it's problems 1 through 5. We discovered that problems 6, 7, and 8 are actually a duplicate of worksheet number 7, which you've done already. So yay, you don't have a lot. Okay, so let's look at problem 1. We have a pressure, we have a temperature, which will convert to Kelvin, we have a mass, we have a volume. What is the molar mass of the gas? So we're going to use the molar mass formula. So big M is equal to mass. Our mass is 7.10 grams. Our pressure is given to us in torr, which is the same as millimeters of mercury. So I'm going to use the R that goes with millimeters of mercury, which is the 62.4 version. And that is Kelvin, millimeters of mercury, mole. Whoops, that's liters. Sorry about that. Liters, mole Kelvin. And I encourage you to include the units because you can cancel out the units to make sure that your final answer is in the units that are representative of what you're solving for. And I'll show you what that looks like. All right, our temperature, again, 44 degrees Celsius, which we'll have to convert to Kelvin, which is 317 Kelvin. And then I divide that by PV. My pressure here, 741 torr. Again, torr and millimeters of mercury are a 1-to-1 ratio. So that's the same as 741 millimeters of mercury. And then my volume must be in liters to cancel the units. And that will be my 5.40 liters. So I do take the time to cancel my units to make sure that my answer is in the right units. And as units, I get grams per mole, which sounds great for molar mass. So in your calculator, you should come up with 35.10 grams per mole. And so that will be the same way that you solve problems 2 and problems 3. Let's look at problems 4 and 5 because they really will bring together a lot of what you know. This says that chemical analysis of a gaseous compound showed it contained 33% silicon and 67% fluorine by mass. And then at 35 degrees Celsius, 0.21 liters of the compound exerted a pressure. Good night. That is a lot of information. But it breaks it down. we want to determine the empirical formula. Now, several units ago, you learned about empirical formula, and you were told if you got percentages, you turn those into grams. So we have 33% silicon. So I'm going to say 33.0 grams of silicon. I'm going to convert that to moles. So 1 mole of silicon is 28.09 grams of silicon. And so I have 1.17 moles of silicon. I also have 67% fluorine by mass. And so I'm going to make 67 grams of fluorine. Now you may be asking yourself, hey, wait a minute, isn't fluorine a diatomic gas? Yay, bravo you. So pay attention to the wording. It's not fluorine gas by mass, it's fluorine by mass. And so 67 grams of fluorine, 1 mole of fluorine, and this is just fluorine because it's part of a compound, and that will be 19 grams of fluorine. So you should find out that you have 3.53 moles of fluorine. If you remember about determining an empirical formula, you divide by the smallest number of moles. So I will divide both by 1.17. So I have 1 mole of silicon in my empirical formula, and I have 3 moles of fluorine in my empirical formula. So my empirical formula should be SiF3. The next part of the problem asks you to determine the molar mass of SiF3. So in your calculator, take the molar mass of silicon and then add to it 3 fluorines. You should get a molar mass of 85.09 grams per mole. Then the rest of the problem gives you all kinds of information. It tells you at 35 degrees Celsius, 0.21 liters of the compound exert a pressure of 1.7 atmospheres, and it gives you a mass of the 0.210 liters of the compound as 2.38 grams. This seems like a great place to use our molar mass formula. So big M, and a reminder, big M is equal to mass RT over PV. And so the mass in the problem is 2.38 grams. R, I'm going to look at my pressure. My pressure is in atmospheres, so I'm going to use the 0.0821 liter atmosphere mole Kelvin. My temperature is 35 degrees, but I will convert that to Kelvin. So I will get 308 Kelvin. Then I have PV on the bottom. My pressure in the problem is 1.70 atmospheres. And my volume is given as 0.210 liters. I'll double check and cancel out all of my units. So I have some Kelvin, Kelvin, I have atmospheres, atmospheres, I have liters, I have liters. I am left with grams per mole. So I set my problem up right. So in your calculator, if you do all that, you should get 168.58 grams per mole. And what that represents is the molecular mass. And if you remember when we went from empirical formula to molecular formula, the molecular formula is some multiple of the empirical formula. So what we want to find out now is if SiF3 is 85.09 grams per mole, but the molar mass of our molecule is 168. It must be some multiple of SiF3. So what multiple is that? So we can take our 168.56 grams per mole and divide it by the empirical formula of 85.09 grams per mole, and find out that we have to multiply by 2. And so our molecular formula is actually Si2F6. And you will do problem number 5 similar to this one. So as you do these problems, if you have questions, please do not hesitate to either send a message via Remind or email.